You say more math, I say let's go. Selected homework problems from 5.3. Start with number 32, which states, find the zeros and give the multiplicity of each. For f of x equals x cubed times x minus 1 cubed times x plus 2. So again, we fully factor. It already is fully factored. And look at each term. Each term is going to have a 0 once it's fully factored. Multiplicity has to do with the exponent. Our zeros are x equals 0, x equals 1, and x equals negative 2. The multiplicities are 3, 3, and 1, respectively. Remember, there's like an exponent of 1 right here. And there we go. That's all there is to number 32. All there is to 32. Wow, Jason, you're so funny. Let's also look at 40. All right, that's also another very similar problem. Zeros in multiplicity. For 2x to the fourth times x cubed minus 4x squared plus 4x. This one's not fully factored. The first part, that's factored, no problem. Second part, not fully factored. So whenever possible, take out a greatest common factor. What do their coefficients have in common? 1, 4, and 4. The coefficients don't have anything in common, but the variables do. We can actually take out an x from everything. What's left over? X squared minus 4x plus 4. Now there's two more things we can do. We can simplify this first part, and we can factor the second part. The first part just becomes 2x to the fifth. We had 4x's, we're multiplying by another one, now we have 5x's. And the second part can be factored. It's a trinomial with leading coefficient 1. So it's going to look something like x and x like so. We need two numbers that multiply to positive 4, add to negative 4. Multiply to positive 4, add to negative 4. Our answers are going to be negative 2 and negative 2. Or you could maybe have recognized using the perfect squares formula that this is a perfect square. So f of x is 2x to the fifth times x minus 2 squared. The zeros are when x is equal to 0 and when x is positive 2. And there's multiplicity of 5 and 2, respectively. Look at those exponents for that multiplicity. And there we go. Let's do 54 next. Use the graph to identify zeros and multiplicity. So just looking at the graph, there is a multiplicity. There's a 0 at negative 4 and negative 2. And what multiplicities do those have? Oh, we lost it. It happened again. Multiplicity 1, it just kind of crosses normally. If you zoom in really close, it'll cross like a line. But there was one more 0, right? One more 0 when x is equal to positive 3. Multiplicity 2, it bounces off like a parabola. Positive 3, multiplicity 2, that's number 54. Let's do 72. So for 72, I don't, the problem wants you to write the formula for the function. I'm only asking you to look at multiplicities and zeros. There's 3 zeros right here. Negative 2/3, something, and positive 4/3. Okay. Equals negative 2/3, something, and positive 4/3. What's that middle one? Let's just approximate it as like 1/2. I think, I'm not sure what it's supposed to be. We could reason it out a little bit, but that's not something you need to be able to do. So let's just approximate it as 1/2. And their multiplicities. Crosses kind of like a line for this first one. Whoa. That one that was definitely my fault on that one. I clicked multiplicity 1, and multiplicity 1. Okay. That's 72. Let us do one application problem, and then that'll be it. Number 78. A cylinder has radius. Okay, a cylinder. We're talking about a cylinder. Let's draw the cylinder. Okay, cylinder. A cylinder has a radius of x plus 2 units and a height of 3 units greater. The radius is x plus 2, and the height is the same as the radius, but 3 bigger. So that's just x plus 5. All right. Express the volume of the cylinder as a polynomial function. Find v of x. So this is what's called wait, I'm losing it. I'm pretty sure it's called like a regular prism or something, or I've already forgotten it. But since it's just like a shape on the top and a shape on the bottom connected like so, the volume is always just the area of the bottom times the height. The volume is going to be the area of the bottom times the height. You can also Google the equation for the volume of a cylinder, and this is what you'll get. Well, what is that? Pi times the radius. The radius is x plus 2, squared times the height, which is x plus 5. This function has a 0 at negative 2 with multiplicity 2. We could say that. But we don't need to. We just need to simplify this out. FOIL out that perfect square, x squared plus 4x plus 4. Remember when foiling out perfect squares, right? This is not equal to x squared plus 4. You have to FOIL it out or use that formula. All right, and then it's a little messy. We have to multiply this out too. Multiply them all by the first, multiply them all by the second, add everything together. Should get x cubed plus 4x squared plus 4x, and then multiply them all by 5, plus 5x squared plus 20x plus 20, and then combine like terms. You do that, x cubed. Oh, there's only one x cubed term. X squared is a 4x squared plus a 5x squared is 9x squared. And then plus x plus 20x is 24x. And then plus a 20 at the end. And this is probably the nicest way of writing your answer. If you wanted to distribute that pi, you could. I think this or this is the best way of writing your answer. On a quiz, I'll just ask for this. Okay. But it's good to be able to do this as well. All right. Hope this helped. Let me know if you have more questions.